Afternoon, all the students are joining soon at the PU webinar Facebook live stream. We are going to streaming over there. And first of all, sir, I would like to give you the introduction about myself and our expert. So this is Arshana Dubey from AC Department, PIET. And today we have the expert over here. His name is Mr. Bin Mukesh, and he is the founder and the senior educator at the Life Robotics. And he's having a 5 years experience with the same field, and he is into the education also. He used to give seminars and webinars on the same robotics. So over here also we respect his valuable precious time that he's giving to us for our students, for our electronics, mechanical and computer IT students, for giving his precious time, and he is going to give us the knowledge, deliver the knowledge about the most emerging technology, that is robotics. So now I hand over to Mr. Mukesh to carry forward, sir.
Hello. Good afternoon, everyone. Yes, thank you so much, Archana ma'am, for this introduction, and thank you so much for this opportunity. Okay, dear students and all the others viewers. So let's start our today's presentation. I'm sharing my screen. I hope this is visible to you. So we are going to talk about the robotics. So when we say a word robotics, then as a normal human being, we think robot means it is a machine that should have hands, legs, head, or something that looks similar to us, and something that can walk, that can talk, it can run and jump. That's it's normal thinking. We think when I had robotics word for the first time, then I think it must be something like this. But when you enter in this field, when you start working on small projects or you make some models, then we find the real definition or the real meaning of robotics. So it's like it doesn't have a fixed shape or it doesn't have a fixed instrument. Any machine that can help us and who can make our work easier, that is called robots. So I'm working in this field. I'm working in the robotics education where we teach how to make different kind of robot mechanisms, how to use different controllers, and make some of the interesting projects or the real life problem solving projects, we can say. So today we will see history of robotics, like how these things have started, and we'll see few old models, what kind of robots were there. Like robots, it's not like robots have started in last 50 years. Okay, the concept was already there from 100 years or 200 years ago. People used to make some of the model, they used to make the mechanisms, and those mechanisms or the models were helping human beings and they were reducing the efforts. So we can put all those things in the category of robots. Okay, so we'll see the history part, and same time our main focus will be the present robotics reaches. Where do we use these robots in our real life? What are the core components and how it works? And even if you have to make our own robot, then how to make these things. That will be our main focus. And same time we'll see few more things, like there are few interesting things like Internet of Things, machine learning, artificial intelligence. So if we get time, we'll talk about that also. And every day people are making something new, and even the children, the school students, they are also trying to do innovations. So we'll try to watch few innovations made by the children. So as I told you, robotics, it is not a thing that has started in last 50 years. It was already there around 100 or 200 years ago. So these are some of the models, some of the examples. Like this is a mechanical duck. So this duck, it can quack, it can drink water, this can eat grain, it can digest. So people have already made these kind of mechanisms where multiple parts can work together, and they can process something input, and they can give some kind of output things. And these were man powered. So that time we had no electricity, or there was no other power source, so it's a handle kind of thing. You just rotate the handle, and the handle is rotating some gears, levers, beams, and all those things are processing. So we'll have a small introduction of these things. Then first, a radio controlled submersible bot. So these two things that we saw, a duck and a doll, these are like, it's not automatic, it's a remote control. We cannot say remote control, it's a hand control. That means you need an operator to control these things. So robots are divided into categories. One is automatic, and second is where we need operator to control them. So these are operator-based robotics, where you continuously need to control them. And when we comes to the automatic, that means you have given your code, you have given instructions, you have given the program, and things are automatically moving. Okay. And when we say the radio control, then it's kind of we can say semi-automatic things. So even the semi-automatic robots or semi-automatic projects that was started in 1898. So again, it's long time ago. So robotics, it's not a new word that we see here, but now the thing is like we are using it everywhere. It is in your hand, mobile phone. It is with your vehicle, with the transport. It is at the hospital. So we are using them everywhere. So we'll quickly come to the current areas of robots where we are using them, and we'll see how to make some of the robots and how it can help us. This is again the history. This is the evolution part, the revolution part, where industrial robotics was started. So industrial robotics like the robotic arm, it was widely used. It is still widely used in the car manufacturing factories. So this part has pushed our industries, and it has taken to a new era. Now everywhere, almost all the industries, manufacturing industries, they are working with the automation process. They are using robots for their components making. Again, we are still seeing the history things. The You must have heard about the Unimate robot. This is because we learn these things as a part of history. Coming to the present, so these are some present examples of the robots. Okay, so as I told you, when we say robot, that doesn't mean it has to look like a human being. Robot that can have any shape. Okay, the main thing is it is following our instructions, and we are able to control them, or it is helping us, or in some ways it is solving our problems. So we'll watch few videos, we'll see these things how it works. Like this robot is the Boston Dynamics. It's a Boston Dynamics big dog robot. So let's see some part of it, and we'll come back to the presentation. uh, Hold on, we need a video here. Yes. So initially, we'll see some of the interesting robots, some of the cool robots that, which is under processing, testing, development, but they exist. And after that, we'll come to the next part, where we'll see how to make these kind of things, or their small prototype versions. So this is a sport mini robot made by the Boston Dynamics. Boston Dynamics is a company that makes this kind of robotic animals, or even they make the humanoid robots. So mainly they make a walking robot that can see things, it can sense surrounding, which can follow instructions, which can carry load. So you can use these kind of robots for carrying loads with you, or they can help you at different places like manufacturing industries, factories, or you can use for the security purpose, infection, and other places. Even Boston Dynamics, they have many projects running for the military purpose. So they are making robots for the military purpose. So these are the current areas, like what kind of robots exist, and we use them. Okay. So we can use these for the daily life. Okay. We can use in industries, hospitals, or we can use for the personal purpose. Now, this is an Indian version. The second one, this middle picture, this is made for the Indian military. It's a remote control robotic arm, we can say. It's a multi-axis robotic arm that can be controlled by the remote. It can be used for the bomb diffusing or to catch something, pick and place purpose. Okay. And the third one, I hope you are aware of this one. This is a Predator. It's a remote control flight system which is specially used in the war zones. Let's watch this video. So the flight robots, they have totally different area, and even the flight robots or the flight machines are like, these are the machines that uses most of the sensors, and their feedback mechanism and programming, it's we can say very high level of accuracies required for these things, because when you are not on the ground, then a small mistake can damage everything. So they are equipped with lot of sensors like pressure sensor, temperature sensor, GPS, locations, cameras, and remote control system for broadcasting, sensing surrounding, radar system. So we use lot of sensors in any flight control system, and this is one of the most advanced, which is used for the war purpose. It's a drone. Okay, I will show some flights and then we'll go to the next part. So this is flight in action, as you can see. The most important part it can fly for long hours, up to 28 hours, with the speed of 260 kilometers per hour, with a non-stop flight, and it can give you real-time data. You can use it for the surveillance purpose. Okay, this is totally different area when we talk about these things, like a robot for a robot remote control flying robot. That is completely different thing. So these are the robots for the security. Now the next is robots for the medical. This is a Da Vinci surgery robot. So even robots are used for the surgery also, and surgery like where we need too much of precision, or suppose a person is not there to handle or to operate the operations, the surgical operations. So that time we can have the Vinci surgery robot. This is one of the most famous and the advanced surgery robot. It has multiple arms, and all these arms are controlled by the different finger sensors Those sensors are over here. You can see this person is sitting in a cabin. This cabin is equipped with multiple sensors and some radio transmitters, we can say. And these, from here, he's trying to control the motors connected to the second part of the robot, where the robot is performing operations. So in the second part, there are motors and controllers and the receiver part, and that this person is sending some commands with the fingers, and those commands are received by the control receiver. That is, receiver is transferring into the controller, and controller is controlling these motors. And there are different motors, lot of motors connected with this robotic arm to make different movements where it can perform operations, and same time the person can see what is happening there. So those arms are equipped with the cameras, and these cameras are doing sending real-time data so that the person can watch from here. So let's see a small video of this also. Later on we'll see how to make this type of remote control robots, or the remote control robot arm system. So the robots are not limited at one place. Nowadays, it is almost everywhere. It is in the field of medical, war, it is for the entertainment purpose, or it is for the education, for innovations, for space, for underground, for underwater. It's like uh, there are models, there are people who are continuously working in these fields, and every day they are coming up with new inventions, or they are making something new. So these are the robots for the medical. Like this is a Moxie, the robot. This kind of robots are used in hospitals at the place of nurse. So suppose if there is a shortage of these healthcare workers, like nowadays we are going through this COVID crisis, so we have the shortage. So in these kind of cases, we can have robots, and the robots can help us. They can deliver medicines, or they can deliver the basic reports, your body checkup reports, and they can help doctors. They can move with them. They can carry the medical stuff for them. So we can use them at the hospitals also, and these are for the home purpose that we are already using. So like the oven and the washing machines, usually we don't consider these things as a robot, but they, up to some extent, they are following our instructions and we are controlling them. So we can tell them that yes, they are also a kind of robot. Okay. It's not necessary a robot has to look like the human being. It should look like a car only. They can have any shape. Even your computer, it's nothing is moving there. There is no movements like the motors or actuators, but still it is considered as one of the robot because it is making our work easier. It is solving problems for us. So when we define the robot, that doesn't mean it has to move somewhere or it should have a mechanical structure, a fixed mechanical structure that can have any shape. And these are some of the robots that we use for the entertainment purpose. And you must have heard about these companies, Sony Aibo and Honda Asimo. It's a world famous robots. We are going to watch this one first. This is made by Lego Education. This is from the Lego Education Mindstorm, the EV3 puppy or the Mindstorm puppy robot. So again, this is a robotic animal, and this robotic animal is making different actions. So there are sensors. So you can see this person is doing something. First of all, he is pressing buttons over here. So that time he is running the program. So there is a code and the robot is following that code. We need to give the instructions. And then next he is coming and pressing this part. So there is one sensor here. Now this sensor is programmed to do something. So when you press these things, then this part is going to be checked in a code, and your code will check what to do when this part is pressed, when the touch sensor is pressed. And the next he's showing some colors. So there must be a color sensor somewhere here. There should be a color sensor. That color sensor is sensing these colors. So when he's showing different colors, like when he showed green, then he's making this kind of actions. Now again resetting by pressing the touch sensor and showing another color. So now this time he's just sitting down and making a heart emojis, showing heart emojis. So this robot is programmed to do different actions, to make different actions when it is sensing the colors. So same way we can give our own instructions, like it can be controlled with sensor or we can control with remote. We can ask it to do different things like this one. When we see other robots, let's watch the Honda Asimo robot. Okay, so I hope you have understood what are they trying to show here. with the sumo robot. So it's a humanoid robot that can be used for play, for fun purpose. We can play games, sports with this robot, or you can ask it to do different things like picking up objects or move around you, do something for you. The small steps. It is equipped with so many sensors, cameras that is giving real-time data, and this is a kind of completely automatic robot. So there is no remote to control it. It is following this code, and based on the sensors or based on your movements, like if you show something to stop, then it may stop there, or if you give instructions to just sit down, so you can show some gestures or some some kind of emojis. It can detect and follow the instructions. So these are for the entertainment purpose. Now coming to the next part, robots for space. This is also one of the very famous things. But exactly what we have to do here. So this was just introduction, like where we use the robots. So we are using it at everywhere nowadays. From your mobile phone to spaceships, everywhere we are using them. But how to build these things? When it comes to build a small design or any prototype of a robot, then there are three things that we need to consider, and these are the core components of the robotics. First is the mechanical parts. So as you saw here, these robots, they have a shape. Okay, they can have any kind of shape. That's not a fixed dimension, but they have a shape, and this shape is made of few materials, and these materials are processing a mechanism. So there is a concept of design, kinematics, dynamics, actuations, degrees of freedoms, levers, joints. So that is a part of mechanical engineering. So mechanical engineering, it covers almost one third part of the robot. The designing part and the movements, that is completely covered by the mechanical engineering. Second core component is the electronics and the electrical part, because of when we see these robots, then all these robots are making some actions. Either it's surgery robot or it's a EV3 puppy robot. So they are moving, they have the hands or the legs. So these things are working with the help of motors and the sensors, and motors and sensors are the part of electronics. So that covers the second half, sorry, second जो है 33% of the robotics. And the last is the computer science, the coding part. So all these robots, if these robots are not controlled by the remote, and if you are making a code to control them, if you are trying to make them automatic, then that comes, there we write the code. So that's the programming, and that is a part of computer science. So we need these three things to make any robot design or any robotics project. Now we'll figure out where are these three things. So let's see another robot and find out where are the mechanical parts, what are the mechanical parts used in this robot, where are the electrical components, and how to involve computer science to control these things. This is Lego Mindstorm robotic arm, and this robotic arm, this is a prototype of robotic arm. It's not the actual or the industrial robotic arm. It's a prototype version, but this robotic arm can be used for pick and place purpose, and especially these kind of arms are used in industries like vehicles manufacturing industries. And it is controlled with the coding, and the person is pressing some buttons, and when he presses the down button, then this robotic arm is moving downside left side, picking up objects from there and dropping in the center. And when the up button is pressed, he's pressing another button, then it is moving right side, picking up an object and dropping it in the center. So all these, as you can see, it has a grabber, this part where it is grabbing something, where it is picking up something. So that part is made with the help of beams or the gears and some joints, some mobile and the fixed joints. So these are the mechanical parts. And these mechanical parts are operated by a motor. There is a motor. You can see this black wire. So this black wire is controlling one servo motor. That is an AV3 medium servo motor. And that servo motor is controlling the gears. So these motors are the electronics parts, or we can consider electronics and electrical components. And here we have some sensors here, like it is moving up with the help of a sensor. There is a sensor here. So this sensor is controlling the up and down movement. So when the sensor senses some light rays, the reflected light rays, then it tells the robot that you have moved up, now you stop there. So it stops there. So that is again a part of electronics. And we have two more motors here. As you can see, one motor here which is moving up and down. This is also a servo motor which is moving up and down, and there is one motor at the base, the bottom part, which is moving it left and right. So like when you press the down button, then it's moving left. So there is one more large motor that is moving left and right. And all these motors and sensors are powered and controlled by the brick. So brick is the main controller here. This has ARM based controller which is controlling the motors and the sensors, and these motors are sensors are connected through the ports. You can see these wires are coming out from there. So the controller is the main part. We can say that is the heart of the robot or the brain of the robot. Okay, and that part is controlling the motors and sensors, and these mechanical parts are giving it a shape to perform a specific operation like pick and place or running, jumping, or anything like that. There is a coding part. So this robot can be programmed with the C languages, Python, Java, or even you can use simple block codes. The block codes are very similar to the making PLC codings. It's a ladder kind of code. And before going to the next part, now would like to come back to the meeting. Uh, Hello, Archana ma'am. Can you hear, ma'am?
Yes, yes, yes,
Yes, ma'am. Is it audible? Are you able to see the videos and the
yes,
audio part?
yes, we can.
Okay, thank you. Thank you. So here we saw where are the mechanical parts, where are the motors, where are the sensors, and the gears, some beams, and the controllers. So when we say robot, that is made of three things. We need all these three things to make one structure. Now, sometimes it is difficult to find out all the things. Like if I'm a mechanical student, then I can say that I can easily find out the materials, I can find out the beams, metal, chassis, or the plastic or other things to make the structure. But finding out electrical and electronic components, sensors, and writing code can be difficult, or that's a challenging task. It's not like it is not possible. We can obviously do that, but that is a challenging task. And when we say we are from electronics, then we can easily make projects using the computer science, sorry, using the controllers, using the motors, using the sensors. That is easy for us. So if you can make a group of different branch students, then you can easily make a complete full version of robots. Otherwise, we can go with the small projects. So today we are going to see some of the projects, like how to make our own robots. Even when we don't have these kind of materials, or we don't have the Lego kits, or we don't have these kind of things, okay, which is difficult to get, but still we can make some robots, we can make some projects at our end. So before starting any design or any project, first of all we need to work on the problem statement. Exactly what is the problem? As we discussed, robots are the machines who are helping us, or who are who are making our work easier. So we need to find out exactly what is our problem statements and what do we have to solve here. define that thing, and then come up with an idea, like what things can be added, like if I add some motors, or if I add some sensors, or if we make a mechanism, or if we change the process, the way it is working. So how to solve these things, that's the main solution part. So it's like we say a rough ideas. We need to make a rough diagram how to solve those things, and then we can go for the prototype. So prototype is the place where we start collecting some material from the market, we start joining them together, and then we make one of the simplest version of the model or of the robot, and then we come to the testing part. So these are the phases that we have to follow. It's better to go through the steps rather than coming from the last step to the first step. So we'll see what are these things. As we discussed, ideas, we need to define that I want to make this type of robot. So you can decide the topics. You can select topics based on global issues or based on some social issues, personal issues. You can build for the security purpose. So global issues, like nowadays, if we have to make a model that can help us with some COVID problems, like the COVID is causing the oxygen problems. So we can work on oxygen concentrator. Nowadays, there are students, my students, who are working on these kind of projects. Social issues. So social issues, like everybody is trying to make the social distancing and other things. So we can think of creating some applications or some projects that can identify whether the rules are followed or not, or it can give alert systems. So we have to decide our topic first. Okay, you see what kind of topic, what kind of problems you have, and then see the topic that it is this kind of issue, and then go and research like what kind of solutions are already available in the market. Or you can go through the internet, and I'm sure you will find some solutions that already exist. Then study those solutions, because that study part will improve your design. So rather than starting a direct designing part, better if you go through the process and find out the old solutions and work on those things, and then find out is there anything missing in that solution, or what is the new in your design, what is new in your idea. Then we can think, or we can work for that. So second is, after idea, the next part is the designing part. And when we come to the design, then we use some of the boards, some of the tools. So these are the tools like Arduino board or TNC board. So these are programming tool, or these are the controllers, and these controllers are used to control the robots. And then we can use sensors, and then the coding part. So we'll see these things how to connect together. But the second part is the designing. So designing is the phase where we have to decide what all components we need. Okay, do we need very big, very heavy, costly components, or we can go with the simple version? And what kind of sensors and motors are required? Exactly what are the specifications of our robot? So as per the robot challenges and specification, we need to find out the parts for that. And the third is, when you are done with the picking up parts, when you have selected that we need these parts, then we can start making a small prototype version. And the prototype version works in a feedback mechanism, or it's a feedback loop, we can say. So feedback loop is like you test something, you apply your logics, you apply your formulas, and get the reading, and see whether these readings are giving the correct output or not. If it is not giving correct output, again you tune something, you make some changes in your coding, or you can make some changes in the designing part in your prototype model, and let it go through the feedback loop. So just keep on repeating the testing part, test, analyze, correct, repeat, and then do something to solve it. So this part is the time when we improve the efficiency of our models, or the efficiency of our prototypes. Okay, so pick up an idea and go through these three steps: ideate, design, build, and innovate part. Now we'll see one of the core component. We are coming to the core components of robotics. So based on these three slides, or these three steps, we are going to see a robot model, how a robot model is designed, and how the robot, how to make a robot by following these steps. So suppose I am picking up a problem where we need to work with with some conditions where we cannot go or we cannot enter. Maybe we can say the chemical reactions or the hazardous place where we cannot go. So I'm thinking to make a remote control robot arm or a robotic arm that can be controlled from some distance and that can perform some kind of actions. So that is my problem statement. So I want to make a remote control hand that can be used in the dangerous situations. Now, the second, we will pick up the components, what all components we need. So we need some circuit making things, tools, boards. So I'm going to pick up Arduino board for this because I am already aware with this one. You can, if you want, then you can choose other boards. There are different options, but always try to, whenever you are working on a prototype version, then try to select a board that is easily available, which is widely used, and where you can easily get the references, because this is a prototype version, and prototype means there can be a lot of changes, or you may come up with new ideas, or you may come up with new things that you want to add here. So it is better to keep it open. Okay, don't restrict the things. And these Arduino and ASP modules, Tinsy board, Bolt, these boards are like there are a lot of references, there are a lot of connectivity. Okay, you can easily connect things, you can easily code, you can easily control them. So go select these type of controllers where we can easily get more ideas. So I'm selecting this one here with some sensors. So sensors, as we discussed, remote control things, so we have to define how do you want to control it. As I said, I wanted to control from some distance, so I'm going to use some receiver transmitter. Okay, and with the hand I want to control it with my hand. When I move the hand, then this has to move. If I'm moving hand left, right, up, down, or when I'm moving the fingers, then those fingers should move. So we need to write down these things on the paper, that these are a part of designing, that these actions should happen, and what are the parts that we need here. Then you will find you need some parts to sense this left and right motion, or different positions, tilting positions. We call it gyro sensor. So let's pick up one gyro sensor for that. And the fingers movement, I want to control those fingers, the robotic hand finger, the same like my finger. So we can use a sensor called flex sensor that can sense the bent angle where you are bending it or not. So we can use a flex sensor for sensing the fingers positions and the bending part. We can use gyro sensor for sensing the angle where you are tilting left, right, up or down. And then we need a controller. That controller will take all these readings. The controller will take the readings and then it will transfer it through the RFID. Maybe not RFID, we can use other receiver transmitter version. So the controller will use that receiver transmitter to transmit these things. So this is one part where we are sending informations. Now the second part is installed on this robotic hand that we want to control. So this robotic hand has one receiver part, and that receiver is ready to receive the signals. So when you are sending something, the receiver is receiving, and then receiver is decoding your signals, that your signal will go in the binary form. It will receive and then it will compile that the this signal means this number, or maybe the text. This kind of signals are coming, and then you can have a program. If the receiving value is this, then do this. If the receiving value is that, then do that. So that's a part of coding. That's a part of third stage where we are making some actions and testing it. So let's see this one, how it works. So you can see this, these are the sensors that we are talking about and the controller board. So this part is the transmitter who is transmitting signal, and these fingers have white strips. That's a flex sensor that is sensing the bend position or the tilting positions. There is one gyro sensor. Sorry, we missed that. It is somewhere here. So that gyro sensor is sensing your positions of the hand, whether you are tilting up, down, left, right, and the controller board. This is a Arduino Nano controller that is taking all these sensors input values and sending these values through the transmitter. And another part of this communication is connected here. That's a receiver part, and that receiver part is receiving those values and giving informations to another controller. So maybe the Arduino is or other controller would have used there. So those controllers are receiving the values, and then they are controlling the motors. So motors are connected somewhere here with the fingers. So when it receives that this sensor is giving some reading, then control motor A. Second sensor is giving some values, control motor B. So it is controlled in this way. This is a normal diagram of a prototype. So this is just one kind of prototype. Now we can use these components and make different kind of prototypes. So whenever we work for the prototype, then most important things are finding out the controller board that you are going to use here, and what kind of sensors can be used. Okay, because sensors are the things that is making it easier for us, or they are sensing the surrounding. So if you add a correct sensor, then you can make it easy compared to others. These are some of the sensors list that you can find, and I think you can pick up any sensor and make at least 10 projects. So there are a lot of projects that can be built using the sensors, and if you add extra sensors, then you can make it more advanced. It depends on our problem statement, what kind of things we need. So multiple sensors can make your project that can add more values, multiple sensors with the correct use of sensors that can add more values in our robots. So now we will see some videos or some robots that has too many sensors. It has multiple sensors and which is following a complex mechanism. So this mechanism was a simple where we are controlling the motors, but the world is not limited here. Nowadays we are using different kind of mechanisms, or there are a lot of mechanisms which is really advanced. Let's watch some of them. So again, this is a part of Boston Dynamics, and we are showing the walking robots of the Boston Dynamics. This project name was 8 plus. So seeing these things are good, but we know that uh, these things are using very advanced process or the mechanism. So we should go with the simple version. We should pick up the small components like this kind of things, or the motors and the sensors, try to connect them. You find out exactly what is your problem statements and what kind of mechanisms are needed for these things. Okay, and come up with some innovative ideas, build a prototype and go through the feedback loop where we can test and make some improvements. And these things can help us in making these kind of structures. So these robots are not limited only to the complex mechanism things. Nowadays, we are controlling everything with the mobile phone, or we are controlling them with the laptop. And the things are like we are controlling from the remote areas. Okay, so it's like the distance part. has increased. You can control it from the other corner of the world. So these kind of things are called Internet of Things. And this Internet of Thing is like, now it has got merged with the robotics. So we call it Internet of Robotics instead of things, where we are controlling our robotic projects. It can be live industrial robotics, or it can be the real-time data of your vehicle, or the sensors which is installed at your farm, or it can be a sensor that is installed in a patient or the person's heart, which is monitoring everything. And these things transfer data on the internet cloud, on the cloud, and that cloud gives those things, those informations to our mobile phone, or we can control them. Okay, so Internet of Thing is a system of connected device, computer sensors, and the digital machines that transfer data over a network, and we are controlling it with some digital gadgets. Now, I would show one of the projects made by my student who is controlling this bulb with his mobile phone. And it's like you can control from anywhere. He's just 14 years old, and he's learning robotics, making this type of models. Even he has made some of the cool Lego robots also. Sorry, let's watch this video first. Yeah. So he's controlling through mobile phone. He's giving some commands. Okay, Google, turn on lights. And those commands are going on the clouds, passing through the internet gateways, and then it is making an action. So it's like if I say this, then do that. So he's using IFTTT platform. Let's watch the complete video. And you can see he's not using any mechanical part. So that is not necessary that you need to give it a design, or you have to give it a shape. The main thing is you work on the idea, you pick up a subject, you collect the components, decide the mechanism, go through it and build it. Okay. So once the things are done, like he has designed this project, he has designed a bulb which is controlled by the voice, a voice control bulb. So once your core part is ready, then you can think of giving it a shape. So that time you can think now your bulb needs a smart bulb shape, or you want to put it in a casing, or you want to use some special PCB board for it, your own PCB board. So you can do it. But it's important to start from somewhere, or it is important to make a rough model. And these are the IFTTT tools that I was talking about. If this, then that. Uh, it's widely used tool that controls different kind of applications. Like you can control your some Facebook applications with the WhatsApp, or you can control your WhatsApp applications with some controller board, like the Node MCU controller board, ESP controller board, or the Arduino controller board. You can connect them with the Google Voice or anything. So it's like this tool is allowing us to connect to different services. Okay. So one service act works as this part, and the second service comes under that part. So if this, then that. So that is called IFTT tool. Just go through it. You will find a lot of informations. You can search about these things. You can find the tutorials how to make this kind of robots, or how to make the projects using IFTT tools. Now the second, so I'm showing few more tools here. So after IFTTT and the Node MCU, we can go with the Bolt tool. This is a Bolt IoT. So this is also, it can be used for the robust purpose, like we can use it very roughly, and it is widely used in industries also. It's very small in size, and you can connect with the internet. It can be controlled with the mobile phone or the laptop. This is another tool, and this is Node MCU. This is also used for making IoT applications. So if you're planning to work on IoT, then you can pick up these kind of tools, like what kind of tools you want, exactly what do you want to do. Then go and find out what kind of libraries you have there. Do you have the correct resource for making these things? Like if you're planning for industrial projects or the big projects, or a projects that is going to work for 24 hours robust uses, then we can think of this product. Or if you are making a project which is under testing purpose, or which is used for a limited time period, we can use Node MCU. Or if the things are going to be completely application based only, you don't need any hardware, then you can use IFTD tools. So we need to find out exactly what are our requirements, and then based on the requirements, you can select the tools, what kind of IoT tools you need to build them. So this is, I was talking about the industrial of robotics, the IoT plus robotics, that is called, sorry, Internet of Robotics. So nowadays it is like we are controlling manufacturing industries. We are seeing all the manufacturing industry real-time data on our mobile phone. So what is the current, how many products are manufactured, how many products are under process, or how many products are faulty or not working, not manufactured properly. We can see all the informations just by one click. That is possible with the help of IoT. We are using it to control the remote areas, remote locations like this, or for making smart cities. And at last, I would like to show some of the innovations, these models made by the students. Okay, they are just 13 to 15 years old students. Let's see these videos. So one of the students has made this robotic arm, prosthetic robotic arm. Let's watch this thing. Sorry, continue. Okay, so it's a story of a student who made a Lego arm just to replace the real one. And see, the idea behind showing this video was we should not worry about the model exactly what are we using these things, but exactly what do you make, how do you make, and how much helpful it is. That part matters. Okay, so you find out the problem statements. The problem statements can be our real life, or it can be a personal also, but we can make some of the innovations. Now let's see another. This is an Indian student. So he had made a braille printer. So he made a design of the braille printer using the Lego parts, and later on this design was adopted by the Intel, and Intel started a new company where he became the CEO of the company at the age of 12 or 13 only. And now they are planning to make a simplest version of braille printer. If you go and find out the braille printer's cost, then the braille printer's actual cost are around 2.5 lakhs. That is just because of the mechanism, the way it is designed, and those things are very costly. So he replaced all those costly things with a very simple parts. So let's see this video. Let's see the inventions. Okay, so this is the thing here. So these are the innovations made by the kids. Okay, so now it's not limited here, as even school students are also making the projects, and so you are in the college, so you should definitely work on these kind of projects where you can make something better, or you can try this kind of models. Now we'll come back to, I will come back here, Archana madam. Hello. Yes, Archana
Yes,
madam.
sir.
So is there anyone who has any doubts or anything? If you want to ask anything.
Everyone are being getting streamed through the help of this Facebook, sir.
Okay,
And
okay, great.
yes, so that's it. Over here, we have all seen these. We understood about robotics. So first of all, students, those who are being over here, I would like to say one important thing that don't get involved only into the theoretical part of the your career. Okay, whenever you're getting involved in your career in your field, go deeply with the something practical. You have to do something practical knowledge that you have to gain with you, because nowadays to increase your skill, practical knowledge is very much required. So, in that one part, the robotics is playing a very emerging and important role whenever you are getting involved in technical, we can say, into a technical skills. And I hope all of you enjoyed this video. You understood about robotics, and this is a very important because nowadays everything is getting automated, right? And we are dealing into many things that can be able to reduce the men work, right? So I expect everyone that if you are getting involved into the robotics, you are taking interest in that, you should at least have some technical knowledge. You should try to make some projects so that it can, because there are many students from Parul University who has made the projects, big projects, heavy projects on the base of robotics. And I want that each and every student, starting from the first year to the final, they should be having a good technical knowledge on robotics. So this webinar was specially for all the electronics, mechanical, and computer students. I hope all of you enjoyed. Thank you so much.
Thank you, ma'am. Thank you so much. Thank you,
And
students.
thank you so much, sir, for giving your precious time to us. Thank you so much.
Thank you, ma'am. Thank you.